So, hello all. Welcome to the IIT Engage classes. In this session, we are going to start a solution for ISRO examination, which is recently conducted. That subject will be strength of material and machine design. So here, if you see, uh, if you see the strength of material and machine design. So coming to the question number one, try to see this question. I will be start solving, but for the next 2 minutes, you please try to observe this question. So now here, if you read the question number one. Question number one, what they have mentioned, a beam is subjected to a beam is subjected to the uniform load WC per unit length, and the MA and the VA and VB are the reaction as shown in the figure. So definitely it is one of the by looking at the reactions, it is a propped cantilever beam. It is a propped cantilever beam, right? So here and then they are asking what is the expression of the shear force and the bend moment. If I draw separately the diagram here, solution for question number one. Here, if you see, so we have the reaction forces. First of all, the reaction force VA, and there is a bending moment MA, and there is a prop reaction which is nothing but VB, which is nothing but VB, and then we have this UDL, which is nothing but. I'm marking this UDL, which is external load, WC Newton per meter. What they have given? WC Newton per meter. Newton per meter. And the length of the beam, you can consider it as okay, WC per unit length, and length you can consider capital L, for example. Now they are asking what is the bend moment and shear force which is given, right? So if you take any section, if you look at the options, they might have taken this section from the left hand side. For example, I am taking here section here. Let us suppose I am taking section here at section x6, which is there at a distance x from the left support at a distance x. At a distance x. Now what they are asking, what is the shear force? What is the shear force? Vx at this one. So what is the sign convention? We know the sign convention for the shear force diagram will be something like this. Whenever we have force like this, then whatever the shear force in this section xx, either we move from the left hand side or we move from the right hand side. The shear force will be plus F. So the similar sign convention we will follow here also for our calculation of shear force. So VA is acting in the upward direction, so it is plus VA. And then you can see there is no effect of movement on the shear force. So what is the effect of WC? WC into X. That is a load which is going to be acting, right? Minus. Why it is minus? Because this load for this particular part will be this much, and it will be acting somewhere here. So that is nothing but WC into X. So that is the calculation for shear force. What about the bending moment? You can also calculate the bending moment at section X6, something like what? VA. Now again, sign convention for bending moment is what, guys? The sign convention for the bending moment, if you see very carefully, we have a section XX and we have the bending moment, for example, we have applied like this. Whenever we apply the bending moment like a sagging bending moment, then what is the bending moment? XX plus M. So VA into X, VA into X. What about this? What about the bending moment because of the distributed load? So there is a minus because that distribution of the load will create the You take a section here, WC and X here. There is a bending moment MA and EVA. So what is the effect of this WC? WC into X, that is a load that will be acting exactly at the center of this particular portion. WC into X. So what we can write is WC into X by 2. So that is the bending moment because of this uniformly distributed load. That is a hogging bending moment. What about MA? MA is acting like a sagging bending moment plus MA. So that should be the answer, guys. If you see very carefully your answer for this question, so which should be the correct answer? CR4 should be VA minus WC into X, and what should be the bending moment? MA plus VA into X. This should be VA into X minus WC into X square by 2. D should be correct answer. D should be correct answer for this question. So this is the example of protect cantilever beam. Now coming to the question number 2, guys. Again, this question is basically belonging to the the concept of welding. So that will be discussed in production subject, production and manufacturing. Coming to the next question, guys. What is the question? The specific stiffness of the material is defined as what? We try to see this question. Specific stiffness will be defined as, so what is the specific stiffness? Stiffness, what is the specific Young's modulus? What they are asking is specific Young's modulus. What is the specific Young's modulus, guys? It is defined as modulus of elasticity to density. Modulus of elasticity into divided by density, E divided by rho. So what is the specific stiffness, right? Because Young's modulus basically what? It is a property of the material which shows the how stiffer that material is, right? Against the basically any no external loading. So here the specific stiffness of the material is defined as the ratio of Young's modulus to density. C will be correct. Coming back to here, the next part. The steel machine element at the critical section is in the biaxial state, where uh, biaxial is a state of stress with the two principal stresses like 300 and 300 megapascal, which is equal in magnitude. Find the wound masses stress in the member. Now, what should be the correct answer, guys, for this question? Again, you see, it is one of the easy part. Again, it is one of the easy part. We also call sigma equivalent, which is equal to sigma YT divided by factor of safety. If you write down the complete formula, then you will write half of what we can write is. For a biaxial means sigma 3 will be 0. What they have given, sigma 1 is given 300 megapascal, sigma 2 which is also equal to 300 megapascal. For biaxial, sigma 3 will be 0, for example, here. So what they are saying, guys, a component is subjected to sigma 1 and sigma 2, which is nothing but both are principal stresses, maximum principal stresses. Sigma 3 will be 0. If you put into this formula, you are going to get something like this: sigma 1 square plus sigma 2 square minus sigma 1
Yeah, hello sir. I think this question is from old paper. It is not part of this paper.
Okay,
59
okay.
actually. Yeah. You can continue solve and move to next question. Quickly you can solve this.
Yes, sir. Sigma 1 and sigma 2 both will be equal. So what we can write? 300 square plus 300 square minus 300. So again, what should be the answer, guys? 300 megapascal. This would be correct. So again, if you see this question, which of the following bearing is not suitable for axial thrust load? So if you see the category in the types of bearing, if you see the types of bearing, what are all the types of bearing we have? So basically, if you classify the types of bearing, we have the ball bearing and the roller bearings, right? We have the ball bearings, then we have the roller bearings. We have the ball bearings, and then we have the roller bearing, guys. Now here, if you see, again, I'm not categorizing here, but if you see the types of roller bearings, so we have the different types of roller bearings and we have the different types of ball bearings. Now coming to here, corresponding to the load which is supported based on the design, based on the manufacturing of bearings, the roller bearing, if you see cylindrical roller bearings. If you see the cylindrical roller bearing, guys, see it very carefully. Cylindrical roller bearings. If you see cylindrical roller bearing, so it is basically mainly used for supporting the heavy radial loads only. Heavy radial loads only. It is basically used to support heavy radial loads only, right? That means it is not it will this particular bearing will not be able to support any kind of axial thrust loads. So which would be the correct answer, guys? D should be correct, right? Because based on the designing cylindrical, whatever the load will be there, that will be totally radial load which is being passing through that, and it can able to support based on the designing of the bearings. But axial thrust load it cannot support. Right? Coming back to the next question here, if you see this question, guys, uh, again try to read this particular problem. A solid bar which is having a 50 mm in diameter, that means let us write on the data. Diameter is given as 50 mm. The length is given as 2000 mm. 2000 mm. Right? It consists of a steel and the aluminum part joined together. Joined together. When axial force P is applied to the system, when axial force P is applied to a system, a strain gauge attached to the aluminum indicates a axial strain of 800. Mm, the units will be micrometer per meter. So this would be mu. The strain which is produced in the aluminum is given as 800. What is the corresponding axial strain in the steel? So if I just draw the diagram, guys, to the diagram. So I'm showing here both the basically the bar which are made up of different material, but the length is same. One is aluminum, other is what, guys? Steel. Both are subjected to end axial force P. Now, if you try to calculate the load in the aluminum, now how to calculate the load in the aluminum, guys? We have already seen that the reaction force will be P, right? Now, whatever the load, if you want to calculate in any section, we have to consider either left hand side or right hand side. So either you consider right and left, you will be getting plus P based on the sign conventions. Again, in the steel, it is plus P. So axial load it is same. Area is also same because diameter is fixed. Common diameter is there. If you see the diameter is fixed. So what should be the stress in steel, and it should be equal to aluminum, because what is the stress formula? P by A. Load is same, area is same. So definitely stress will be same. Now, according to every material which we are studying in the strength of material, follow Hooke's law. Within the elastic limit we are loading. So stress will be directly proportional to strain. If I remove the proportionality, it will be E into E into strain. E into strain. Now understand, guys, E into strain. Now try to understand the next particular part. What we can write? E of steel, strain in the steel. E of aluminium, strain in the aluminium, guys. Now, my different, what is the value of Young's modulus which is given? Young's modulus for aluminium or steel is what, guys? 200. Strain in the steel, that we need to find. What is the Young's modulus for the aluminium? 70. And what is the strain in the aluminium, guys? That is given as 800. So if you try to calculate the strain in the steel, you are going to get what, guys? So it is going to be 280 micrometer per meter, right? So this should be correct answer. C should be correct. C should be correct, guys. Now coming back to the next question. Coming back to the next question, guys. Now observe very carefully. Two flanges are connected by the single bolt, which is having a nominal diameter 10 mm. The nominal diameter is basically what, guys? 10 mm. Try to observe. And it is preloaded. They have given the preloading. For example, preloading I'm calling Fi, which is given as 30 Newton meter. But they have given the external load also, that I'm calling F external, which is given as 10,000 Newton. The torque coefficient is given as 0.15. And what is the value of joint stiffness constant? Joint stiffness constant 0.2. That means C value is given 0.2. If you go through the lectures of bolted joints, in that it is given. It is there for the gate examination also, that particular syllabus. But very rarely and very few times they ask in gate examination. So those who have not studied, so they may find difficulty in this particular question. But those who have studied, definitely no, you might have attended these particular questions. Uh, but here the main thing is that we need to remember the formula. What they have given? The torque coefficient. The torque coefficient K is what? 0.15. The torque coefficient is given as, guys, 0.15. Right. The joint stiffness constant is given as 0.2. The maximum tension in the belt is what? The maximum tension in the belt is what, guys? So if you want to calculate the maximum tension in the belt, first of all, we need to calculate. First of all, we know that torque is equal to what? K times of Fi into D. The diameter of the bolt I have represented with a small d, so I'm writing here small d. Small d. K into Fi, K times of Fi into D. From here, the torque, what the value they have given torque? 30 Newton meter, right? 30 Newton meter, correct. If I convert in mm, so it will be Newton mm. This unit is what? Newton mm. What is the K, guys? K is 0.15. What is the Fi? Fi is what given? Uh, Fi, we need to just wait. Here, this value is not Fi. This is nothing but torque they have given. If you see the unit, this is the torque. Fi, we need to calculate into D. D is what, this? 10. So from here, if you try to calculate Fi, so 30,000 divided by 0.15 divided by 10. So you are going to get around 20,000. 20,000 Newton. This is called as initial tightening load. It is also called as preload. This much of load is required for basically without any leakage or leak-proof joints. Now, what is the next particular task? We need to calculate the external loading also. Because of external loading also, what is happening, guys? Some load will be, it will carry, the bolt will be subjected to some load. But what is the, see, if you see the member, so this is a flange joint, for example, and this is a bolt. So bolt is subjected to both external load as well as it is subjected to initial tension load. So initial tension load, already we have found it out. What is the external load which is carried by only the bolt? Because you know that external load will be carried by both. If you write down the external load or total external load, it is basically carried by bolt. It is carried by basically by the also called as flange member. flange members. But we need to find only for the bolt. Then what is the formula, guys? C times of F external. Because 1 minus C time will be carried by flange member. Again, I'm not deriving any formula here. Directly, we need to remember all the formulas, right? C is what, guys? 0.2. F external is what, guys? So if you try to calculate a point, it is nothing but 2000 Newton. Now, if you try to find total load on the bolt, total load on the bolt, Fi plus in the bolt some external load 20,000 plus 2,000. So if you write down the values, it is 22,000 Newton. So what should be the answer, guys? Answer must be C. So if you remember the formulas, questions will be easy. Otherwise, question will be difficult. Moving back to the next question, guys. Here, if you observe very carefully, the square bar of size
Sir,
10 by
again,
10.
please skip this question. This is from previous paper.
Okay, again, this is a question from some different exam, not from this. So you can just go through, just pause the video and you can solve it. We are moving, we are moving just back to the ISRO question. Yeah. If you see this question, guys, all of you can observe very carefully. Again, this question is from the strength of material. A 0.2 mm thick strip is bent and laid over the frictionless pulley. So if I draw the rough diagram, again, this question is already being asked in GATE examinations. So it's a totally repetitive question, but data has been changed. So if you see, there is a pulley, and sorry, on that pulley we have the a 0.2 mm thick strip which is bent over that pulley. So if we write down the radius of curvature from the center, it is passing from the center to the neutral axis. The neutral axis will be exactly midway of the strip, this 0.2 mm strip. So if you just take the cross sections of this one, understand this is the neutral axis, and this total is what, 0.2 mm. So what about the y max, the distance of top and bottom fiber from the neutral axis? It is 0.2 divided by 2. It is 0.1 mm. And what about the radius of curvature? This would be the radius of curvature, which is nothing but which is given as what is the value, guys? The friction is, it is given as the diameter of what is the diameter? The diameter is given as 25 mm. 25 mm. So if you take the radius, so it will be d by 2, which is nothing but 12.5 mm. 12.5. Actually, it should be, if you try to write down the exact value, it should be d by 2 plus t by 2. But again, the thickness is very, very small as compared to the radius. So we are writing exactly to the what? D by 2. So this is 12.5 mm. So what is the maximum stress? What are the maximum bending stress in the strip? So you know the formula of m by I is equal to sigma by y e by r. That is the bending equations. Now here, if you try to compare these two terms, so you are going to get sigma max, which is nothing but E into y max divided by r. What is the Young's modulus? Which is given as 100 gigapascal. 1 gigapascal is 1000 megapascal. Y max is 0.1. R is what? 12.5. So from here, what is the sigma max, guys? Sigma max, if you try to calculate 100 into 1000 into 0.1 divided by 12.5, so you are going to get 800 megapascal. Which will be the correct answer? D should be correct. Now, moving back to the next question, guys. Here, what we have. If you see the 50 mm solid diameter solid shaft is welded to the flat plate all around by the fillet weld of 4 mm leg size as shown in the figure. What is the leg size? They have given the leg size, which is nothing but the leg of the welds. The leg of the welds is given as the leg size is given as, for example, leg size I am denoting with the T, which is nothing but 4 mm, which is nothing but guys 4 mm. What is the maximum approximate torque in Newton meter that welded joint can sustain under pure torsions? But before that, allowable, what is the allowable shear strength? 100 megapascal. 100 megapascal. So please try to note down. Here, if you see the formula for the twisting, when it is subjected to twisting, because of the twisting, some shear stress will be developed. Torsional shear stress. What is the formula, guys? T divided by 2 pi r square into h. See, we have used this formula. T by j is equal to what? Tau by r, which is nothing but tau is equal to what, guys? T into r by j. This is the formula we have, my dear friend. Try to understand. This is what the formula we have that you need to understand. Now, whatever the formula polar moment of inertia we are using for the thin section, not thick sections. So directly I have written the formula. H is nothing but throat thickness. Throat thickness, which is given as T divided by root 2. That is the relationship we have. So what is the value of tau, which is equal to tau allowable? That is nothing but 100 megapascal. T, what is the T, guys, that we need to calculate? 2 pi R. What is the R, guys? R is nothing but 50, no, 50 by 2, which is nothing but 25. H is what? T by root 2. So from here, if you try to calculate T value, you are going to get 100 into 2 into pi. So if you try to calculate this 100 into 2 into pi, now into 25 into 25 into 4. So what you are going to get, guys? You are going to get 50, 500 into 10 power 3 into pi Newton mm. But they are asking in Newton meter, then we need to divide by what? This should be divided by root 2. We need to find in Newton meters, then we need to divide by what? 1000. If we divide by 1000, so what you're going to get, guys? T value. The T value should be 500 divided by root 2 into pi. That should be the answer for this particular question. So try to see which option is missing. 500 into pi divided by root 2. A should be correct. Right. So all we need to do is that, we need to remember the formulas in examinations. Coming back to the, again, this question from machine design. If you see here, what they are asking, the diagram below shown is for the various criteria of fatigue failure, various criteria for the fatigue failure. In this fatigue failure, they are asking which of the following is a correct representation of this criteria. Suppose E, Y, U represent the endurance, yield, and ultimate strength respectively. So this is the graph we have seen: sigma variable stress versus mean stress, variable stress versus mean stress, variable stress versus mean stress. If you look into this formula, then we know that what is the graph for one? What is the graph for one, guys? Which is connecting the line from basically the endurance strength to the yield strength. Definitely, it is nothing but Soderberg line, right? So this line is basically what, guys? Soderberg line, which is the safest theory for a good theory for ductile material. Now, my dear friend, what about the second, if which is connecting the line Endurance strength to the mean strength, right? Endurance strength to the mean strength. Now here, if you see the second line, which is this one, guys, this is nothing but Goodman line. Second line is basically for what, guys? Goodman line. What about the third one? It is for the Gerber line. It is for the Gerber line. So if you see, the first one is for the Soderbergh, the second is basically for Goodman, and third is for the Gerber. So A should be correct. A should be correct, guys. Right. Now moving to the next question. Again, if you see, yeah. So this question I will take in the end. Yeah. So now here, my different the next question. The general bearing which is having a radius R1, the general bearing which is having a radius R1 and the radial clearance SC1 has a Sommerfeld number S1. Has a Sommerfeld number S1. Another general bearing which is having a radius uh, again, let me check the question. Again, the general bearing of radius here we have R2 and the radial clearance is what, guys? Asking all other parameters that need to be remains R2 is or 2 times of R1, and then what should be the Sommerfeld number for the second bearing to the first bearing. So yeah. So if you see, guys, the formula for the Sommerfeld number, if you see the formula for Sommerfeld number, it is a dimensionless term, right, used in the bearings to compare the performance of each and every bearings. Sommerfeld number, which is given as Zn by P D divided by CD whole square. We can also write Zn by P. D is the diameter. If you take the radius, so it's a D by 2. So R divided by C whole square, where C is what? A radial clearance. If R is the radius, C should be the radial clearance, D should be the diameter, CD should be uh, diametral clearance. Diametral clearance, guys. Now, if you look at here, if you see and try to understand, Sommerfeld number, we need to find the ratios S2 by S1. So what we can write? Other parameter need to be remain constant. That means viscosity, Z is a viscosity, N is a RPM, P is a pressure, right? This particular term will be constant. So what I'm doing, I'm just comparing R2 by R1 whole square, C1 by C2 whole square. What should be the R2 by R1? It's a 2 whole square. What is the C1 by C2? It's again 2. So if you see, guys, you know, it is basically 4 into 4, which is nothing but 16. C should be correct. That should be the ratio of Sommerfeld number for the second bearing to the first bearing. Now, coming to the next question, guys, try to understand this question. We need to match the following: the theories of failure and the shape of the region to the corresponding theories of failure. What should be the safe region beyond which, if you load the material, it will fail? What should be the safest boundary? So if you see the Rankine's theory, basically we have the square shape of the regions. What we have, guys? We have the square shape of the regions. So if you see the Rankine's theory, it is a square. If I draw the diagram, sigma 1 versus sigma 2, see, we can draw this shape of the region for 2D, right? So if I draw for 2D, sigma 3 will be 0. So in that case, we are going to get square. So again, here we have this theory, Rankine's theory, which is suited for best suited for brittle material. Now, this is the Rankine's theory. What about the Tresca's theory, guys? What about the Tresca's theory? Tresca's theory, everybody know that it is nothing but what is the shape? Hexagon shape. So if you see, it is exactly the same, but only the difference will be in the second and fourth coordinates. Second and fourth coordinates. So this should be the shape of the region, guys, which is nothing but hexagon. Right. right, guys? So this is nothing but what we have discussed theory. What about the next center variance theory, guys? Center variance theory, if you try to draw, you are going to get the rhombus shape. Center variance theory, if you try to basically see, you are going to get a rhombus shape. So if you draw here sigma 1 versus sigma 2 here, you are going to get something like this, guys. How you are going to get? How you are going to get, guys? How you are going to get? You are going to get something like this. You are going to get something like this, guys. The shape will be rhombus shape. This is for center variance theory. Center variance theory. What about next, guys? Von Mises theory. Von Mises theory. Von Mises theory, guys. If you see the von Mises theory, you are going to get what, guys? You are going to get ellipse. We try to plot the von Mises theory, which is nothing but maximum distortion energy theory. Sigma 2 versus sigma 1. So you are going to get the ellipse, guys, which is having semi major axis A, semi minor axis B. So again, you are going to get ellipse for what, guys? Maximum distortion energy theory. We also call this as von Mises theory. So if you see option, which option is correct? A is for basically A is for what, guys? Third. This is the third, and this is the fourth. A is for third. Then B is for what, guys? B is for Tresca's theory. What is the Tresca's theory? Hexagon. B is for the B is for the first. B is for the first, guys. B is for the first. So C should be correct. Again, C is for the fourth. C is for the fourth, and the fourth is for what? Fourth is for the second ellipse. C should be correct answer. Again, whatever the things we are doing, this is for the set E. Set E is for examination set E. Mechanical paper. Again, this question is belonging to production, guys. That will be discussed production and manufacturing. Right. Again, but here also you can answer. There is no difficulty at all. If you try to observe, it's a very easy question. E is, if you see the E graph, stress versus strain diagram. So what you're going to get, guys? Straight away you can say that it is a brittle material. E is for the brittle. But if you see in the A and C, both the options are what? Brittle. But what about F, guys? If you see F, what about G? If you see, it's a perfectly plastic materials, right? And what about the F? What about G? It's a plastic. What about F? It is what, guys? Ductile material, which is having little bit more elongation as compared to total elongation. If you see in the ductile material, it is more. So what should be the correct answer? A should be correct, right? Again, in the metal forming also we study these graphs, right? But in strength of material, we don't load the material beyond the elastic point. Now, next particular question again, it is one of the GATE 2022 GATE 2020 question, which is a very similar question already they asked, but with a different data, right? So if you see, guys, a machine member is subjected to fluctuating stress, which is fluctuating as a cosine curve, sigma naught cos 5 pi t. Please check it out, 5 pi t. Then the endurance limit for this particular material is what? 350 megapascal. Then yield strength for this material is basically 500 megapascal. Factor of safety we are calling N 3.5. The maximum allowable stress sigma naught. What should be the maximum allowable stress sigma naught according to Soderberg criteria? According to Soderberg criteria. According to Soderberg criteria, guys. So first of all, we need to find what is the mean stress, what is the variable stress. If you know that, if you see the what is the maximum value of the any cosine curve, plus minus 1, plus minus 1, right? So what should be the sigma max? Sigma max is sigma naught. What is the minimum stress? It is minus sigma naught. What about the mean stress, guys? Mean stress will be sigma max plus sigma minimum by 2. So it is 0. I'm calling this to be as sigma mean, which is equal to sigma m. Variable stress, sigma max minus sigma minimum divided by 2. Now, what is the variable stress? Sigma max. What is the sigma max, guys? Sigma max is sigma naught minus minus of sigma naught divided by 2, which is nothing but what, guys? Which is nothing but sigma naught. So, if you try to calculate, sigma mean is 0, sigma variable is this one. Now, according to Soderberg theory, we know this particular formula, right? Variable stress is what, guys? Sigma naught. Sigma E is what? 350. What is the mean stress? Mean stress is basically we have, it's a 0. What is the sigma naught, guys? That is what they are asking. 350 divided by 3.5, which is nothing but 100 megapascal. 100 megapascal. Now, according to this, which should be correct? C should be correct. C should be correct. Coming back to the next question, guys, if you observe this question, a plane stress. Again, this question is belonging to machine design, where maybe you can also say strength of material, theories of failure. The plane stress element in a structural member loading is given as sigma x. That means if I draw here, sigma x is basically what we have 4p, sigma y we have 2p, again to maintain the equilibrium. Now again, tau xy, here we have the tau xy, one value which is nothing but root 3p. For example, I'm drawing here like this, which is nothing but root 3p, where p is greater than 0. The yield strength of the material is 300 megapascal. If the member is designed using the maximum shear stress theory, then the value of p at which the yielding will be start taking place is what? Then the value of p at which the yielding will be started taking place will be what? So for calculation of this one, for value of p, we need to basically what, guys? We need to calculate according to Tresca's theory, but we know the formula. What is the Tresca's theory? According to MSST, for the material to be safe, whatever the tau max should be there, which is nothing but what should be the value? Sigma 1 minus sigma 2 by 2. This should be the maximum of tau max should be tau max which we are calculating. This should be maximum of this value, this particular value. Now my defend here, if you try to see, according to MSST, these are the formula. This should be less than or this tau yield. Now according to MSST, what is the tau yield? This value we know that sigma yield divided by 2. Sigma yield divided by 2. For a basically, if you try to see, this is the biaxial, so sigma 3 will be 0. But what about sigma 1 and sigma 2? Plus minus sigma 1 minus sigma 2 by 2 whole square. Sigma x plus sigma y. What is the sigma x, guys? 4p plus 2p divided by 2 plus or minus sigma 1 minus sigma 2. So it is nothing but 4p minus 2p divided by 2 whole square plus tau xy. What is the tau xy? Root 3p whole square. So if you try to calculate, it is one of the easy calculation. No need to get fear of under root and all. You will be getting sigma 1 and 2, which is nothing but 5p and p. Sigma 1 is what? 5p. Sigma 2 is what, guys? P. Sigma 3 is what, guys? 0. So if you try to put into this formula of Tom x, what you are going to get, guys? Tom x, you are going to get sigma 1 minus sigma 2 by 2 minus sigma 3, sigma 2 minus sigma 3 by 2 minus sigma 3 minus sigma 1 by 2. So if you try to see what is the maximum value, sigma 3 and sigma 1. So what should be the criteria that will be deciding the failure? P should be 60 megapascal. P should be 60 megapascal, guy. If you load it beyond that, it will fail. What about the radius of the Mohr circle? If you see the Mohr circle, if I draw for the uniaxial state of stress, then what about this? What about this radius, which is nothing but Tom x? So radius of the Mohr circle will be maximum shear stress. Now this is again one of the good question. Good question. Try to understand this question, guys. A round wire helical spring is loaded by the axial force. That means if suppose if I try to see, guys, this one. This is the helical wire which is subjected to axial force, for example. With respect to total helical spring setup, this will be subjected to axial force. But if you see only the spring wire, you see only spring wire like this. You see only spring wire which is subjected to some axial force like this one. This wire will be subjected to direct shear force. This wire, it will be, if you transfer the load, there is a direct shear force plus there is a twisting moment. Because of that, torsional shear stress will be developed. So because of this, there is a direct shear like this, tau 1, and because of this, there is a tau 2. So if you see the this inner fiber, it will be subjected to tau 1, tau 2 both, which are both are acting in the downward direction. So the inner fiber will be subjected to what? Total maximum shear stress. They are asking maximum shear stress because of the direct shear force, because of the twisting moment. What should be the maximum shear stress? Where exactly they are acting? So this is the outer fiber, and this is the inner fiber. So B should be correct, right? Because if you see the outer fiber, the direct shear tau 1 and tau 2 both are in opposite directions. So it is not what adding. But here, if you see tau 1 and tau 2 both are acting what in the same directions. So they will be added together, right? Now, guys, if you see the next part of the question, next question here, and look at very carefully, the power is transmitted through a spur gear. The power is transmitted through spur gear. The power is transmitted through spur gear like this, where exactly we have something like this. Now, this power transmitted, which is happening here, it is subjected to what? The tooth of the gear is subjected to the force like this. If you see the both the component of this force, one component will produce the tangential force, other component will produce the radial force. One component will produce the radial force, other will produce the tangential force. If you transfer this load, if you see the side view onto the shaft, this is the gear, the radial force, we have this tangential force. Tangential force will produce the twisting moment if you transfer the load. Of course, there is a horizontal bending moment also will be there, and horizontal bending stress will be produced. And but apart there is a bending stress, and because of the FT there is a twisting moment, and because of that torsional shear stress will also be there. So what we can say, guys? So there is a normal stress due to the bending, and there is a shear stress due to the torsion because Fr will produce the bending moment. And because of that, there is a bending stress will be developed. It will bend like this. And because of the FT, it is a twisting moment. It is creating a twisting moment and it is creating a bending moment in a horizontal plane. So there is a normal stress due to the bending and shear stress due to the torsion. This should be correct. If you see the next part of the question, guys, this particular paper, what they are asking if the load is acting on a ball bearing is increased two times, then its life will again. If you see the previous year question paper of the ISRO, it's a very repetitive fashion questions. Multiple times they ask this question, and again they have asked, one more times, right? So if you see the load life equations, if you see the load life equation, if you see the load life equation, guys, then we write F, the life of the bearings, something like this, equivalent load. So what we can write, L1 into P1 cube is equal to what? L2 into P2 cube. Where C is what? Constant for a particular bearing. Constant for a particular bearing. Now, what is the life of the bearings? For example, we need to calculate L1. Now, what is the load? Load they have increased two times. So P1 E cube. L2 is what, guys? We need to calculate P2 is what, guys? Two times of P1 cube. So if you say try to see the value of L2, which is nothing but L1 divided by 8. So what is the what is the life of the bearings? Will be reduces by 8 times. C will be correct. Now, if you see the next question, what they are asking, guys, the old clutch. We have the clutch basically two types, old clutch and the new clutch. But if you see the old clutch basically they are designed by what? Here only are writing uniform wear theory. New clutch they are designed by uniform pressure theory. The inner and outer radius is what, guys? 100 mm, for example. The force required for the engagement mu is what, guys? 1 upon 3. 1 upon 3. Assume 1 upon 3 for the uniform wear theory. What is the torque? 100 Newton meter. Now, the force required for the engagement is what? Again, what is the axial force required for the engagement? We know that mu into W into friction, that is the friction radius. What is the friction radius for the uniform wear theory? Mu into, this is the friction torque formula. This is the friction torque formula. But they are asking what is the value, what we need to find? We need to find the force required for the engagement. Force required for the engagement, guys. What will be the force required for the engagement? So this is the formula for frictional torque. Mu W into frictional torque. What is the frictional torque formula, guys? 100 Newton meter. Mu, what is the mu? 1 upon 3. W, what is the W, guys? That we need to find force of the engagement. R1 plus R2, 100 plus 200 divided by 2. But here, this unit is what? Newton meter, that we need to convert into Newton mm. So if you try to calculate, you are going to get W as 4000 Newton, which is nothing but 4 kilonewton. A should be correct. Now, the next particular question, guys, if you observe very carefully what they are asking, read the problem first of all. Elastic strain energy stored in a rectangular cantilever beam due to the bending moment M is applied. At the end is given by sigma by which particular formula? So whenever any beam subjected to bending moment, so what is the formula for strain energy due to bending? M2 is square into L divided by 2 EI. M2 square into L divided by 2 EI. For example, we have this one, right? Then what we have, guys? M2 square L divided by 2 EI. If you see the maximum bending stress, sigma max, M into Y max divided by I. M into Y max divided by I. M into Y max divided by I. But if you see M, we are writing what? M2. Y max divided by I. So here what we can write, we can replace M2 because there is a no role of M2 into the final answer. So M2 will be replaced by what? Sigma max whole square I square divided by Y max square into L divided by 2EI. Now what is the formula, guys? Sigma max square I will be what? Cancel out. So it will be I only into L divided by 2E. Bending. Now we need to, put the values, guys. Put the values. Sigma max square. See, directly direct formula will not be given in the problem. You have to put some effort. You just need to solve 2, 3 more steps in the examinations, right? Sigma max square, I is what? I is B for the, if you see the bending which is happening about this axis, neutral axis. So the formula is what? BHQ divided by 12. BHQ divided by 12. Now my different length, I'm writing here length as L. Y max here 2E. Y max is what, guys? H by 2. So if you see U of bending, so what you can get, guys, here? If you see here, Y max is square, so it is H square by 4 because H by 2 whole square, H square by 4. So here what you can get, sigma max square B H L divided by what, guys? 6E. If you see the rectangular beam which is having a length, width, and height, for example, if I draw here length, width, and height. So what is the volume? LBH. So if you replace this particular formula and if you put into the bending strain energy, sigma max square into V divided by 6E. So what should be the correct answer, guys? The correct answer should be sigma square into V divided by 6E. Okay, so here if you try understanding the stainless steel rod, try to read the problem for the first 1 minute. A stainless steel rod of diameter 12 mm, length of 2.5 meter is kept on a frictionless surface and it is heated from 300 Kelvin to the 400 Kelvin. Kept on a surface. If if I draw the side view, this is a frictionless with a surface where the steel rod is being placed, which is having a certain diameter, having a certain length. The coefficient of linear expansion will be alpha is what, guys? 10 to the power minus 5 per Kelvin. The yield strength is basically what, guys? 200 megapascal. E is what, guys? 210 gigapascal. 210 gigapascal. They are asking what is the thermal stress. If you try to see, if you try to heat it, it will be expanded and it will try to take the shape of like this. So freely it is expanding, freely it is contracting, depending on the increment or decrement of the temperatures. So if there is a free expansion or free contraction, there will not be any thermal stress. Total stress will be zero in the absence of any external load on the system. So this would be correct answer, right? A point load about applied at a shear center. Whenever we apply the load at the shear center, so there will be what guys? What we say? What is the meaning of shears? What do you call if you just apply the load exactly at the shear center? What will happen, guys? The shear center is the point about which the member is subjected to what, guys? The member is subjected to what, guys? Pure bending without any kind of twisting, right? So the point load, when the point load is applied exactly on the shear center, so there will not be any twisting. There will be only bending, guys. So this would be correct. This would be correct, guys. Now, moving on to the next question here. Again, this question is not belonging to this sort of examinations. Let me check here. Okay, anyway, we can able to calculate this one. Body is subjected to biaxial state of stress as shown in the figure. What is the magnitude of the normal and shear stress acting on a 45-degree plane? 45-degree plane. Here, 45 degree. If you see, if I take the plane, if I take a plane at an angle 45 degree, for example. So theta is what, guys? Minus 45 degree because it is a clockwise from the vertical plane. Right. What about sigma x? Sigma x is plus 60. Sigma y is minus 40. Tau xy is plus 30. What is the formula for sigma and theta? Sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. Now, if you try to see and try to put into the formula and try to calculate it, if you try to see, guys, if you try to put into the formula, sigma x is what? 60 minus 40 by 2 plus 60 minus will become plus. And what is the cos? Cos 90? Cos 90 will be 0. Tau xy sin 90 will be 1. What is the sigma and theta? 60 minus 40, that is 20. 20 by 2, 10 plus 30, which is only about 40 megapascal. What is the tau s theta? Sigma x minus sigma y by 2 sin 2 theta minus tau xy cos 2 theta. Now, if you put into this formula, what you can get, guys? Sigma x is 60 minus 40, that is become plus 40. Sin 90, cos 90, again it will be 0. So this answer will be what, guys? 50 megapascal. So 40 and 50, that should be correct. This will be the correct answer, guys. Coming back to the next question from the strength of material. Try to go through the question, guys. If you go through this question here, what we're getting? 3 metal balls which is suspended from the 3 wires of equal length arranged in the series sequences. The mass of the ball starting at the top are 2 kg, 4 kg, 3 kg. The wire diameter are of the same order 2 mm, 1.2 mm, and 1 mm respectively. What is the correct order of increasing the stresses in the wires? See again, whatever the weight is given, that you can consider as a load. So what is the load in this member? For example, I'm writing here it is A, B. Sorry, already that notation is given. So I'm writing 1, 2, 3, 4. 1, 1, 2, 3, 4, 7. What is the load in the section 3, 4? What is the load in the section 3, 4? For example, 3, 3G. That is the load which are acting, right? What is the load which are acting in 2, 3? Again, 4 plus 3, because 4 and 3 both will be there. 4 plus 3, which is nothing but 7 into G. What is the load in the 1 and 2? Load in 1 and 2 will be 2 plus 4 plus 9G. My dear friend, if you see what is the wire diameter, the wire diameter for they have given for 1 to 2 sections like 2 mm. Wire diameter for 2 to 3 is given as 1.2 mm. But the wire diameter for 3 to 4 is given as 1 mm. What is the correct order of increasing these stresses in the wire, guys? Wire, guys. Now here, if you consider the wire A, I'm writing it as sigma 1 and 2. So what is the load 1 and 2 and area 1 and 2? What is the load? What is the load 1 and 2, guys? What is the load 1 and 2? The load 1 and 2, if you see the 9, G divided by, what is the area, guys? Area will be pi by 4, 1.2 square. What is the sigma B? Load in the 2 to 3, load 2 to 3 will be 7G, for example. And the area, if you try to see pi by 4, 1.2 square. Sigma C, what is the sigma C? Sigma C will be, my different 7, here it will be 3G divided by pi by 4, 1 square. So if you try to see sigma, if you try to compare the diameter versus this one, and if you try to take this 7 by 1.2, sorry, here diameter 1 to 2 is not 1.2, it is exactly 2. It is exactly 2. So sigma B, if you see, it is more than sigma C, it is more than sigma A. You can calculate 7 by 1.2, 9 by 4. So it is 2.25 something, 7 by 1.2 square, 9 by 7 by 1.2 square, it is something like 4.86, and then we have the 3. So the least will be subjected to what? The last wire, because less load is acting, and moreover, uh, even though the diameter is less, but the load is less. Diameter is less, but the load is more. The load is also less. So if you see, the correct order will be what, guys? The correct order of increasing the stresses will be BCA. B will be correct. What I'm saying, you are understanding? 9 by 4. If you see the 9 by 4, 2.25, G by pi by 4, something I'm calling constant, for example. Sigma B, what is the sigma C? 7 by 1.2 whole square. It is 4.86, for example, C. What about sigma C? It is 3. So you can see that. You can compare the coefficient of C. Right? Sigma B, which is more than sigma C, least will be A. Least will be A. Right? Okay, guys. So if you try to see this question, the next question that determine the equation of an elastic curve for a cantilever beam uniform cross section as shown in the figure, which is subjected to. Now again we should know the direct formula. What is the deflection formula? End deflection. Whenever any cantilever beam subjected to end moment, ml square divided by 2ei. Right, guys. That means if you try to follow the double integration method, so by that also you can get these answer very easily. If you take a section xx here, and if you try to write down ei d square y by dx square mxx, mxx, which is nothing but plus m. So if you try to integrate 2 times, what you are going to get, guys? M into x plus c1 ei into y is equal to what? Mx square divided by 2 plus c1 into x plus c2. So if you put the boundary condition that at x equal to basically what guys? At x equal to L, the deflection will be 0. At x equal to L, slope will be 0. You can get C1, C2. And the final equation will be what guys? Mx square divided by 2EI. We can calculate the deflection by using this particular formula. If I try to calculate, maybe you take this section from here rather than taking here. You can take this section from here. Mm, you take this section from here. If you take this section from here, then you can write like this. Okay, because if this is the bending moment, this will be bending moment m. So bending moment at any section will be what guys? From both the ends, it is plus m, right? Like this. And for your, if you have any further queries at x equal to 0, y will be 0. At x equal to 0, dy by dx will be 0. Put both the boundary condition and try to calculate C1, C2, you can get the answers. So what should be the correct answer? This should be correct. Yeah. Again, the next question again from the machine design guys. Try understanding. What is the true with respect to self-locking? Self-locking, you need to understand two conditions. For self-locking, you need to understand theta should be less than tan inverse of coefficient of friction. Theta should be less than angle of frictions. Theta should be less than angle of friction. So that if theta will be less than 5, it will not be fall down by its own. Self-locking means it should not fall down on its own. On a self, basically, that is a condition for self-locking of a screw jack with the square thread. So this option is correct. First, the efficiency will be not more than 50%. This is also correct statement. This is also correct statement, guys. Please try to note down. The maximum efficiency is 50%. We cannot achieve more than that. That is also correct. So both these statements are correct. Again, screw jack, square thread, multiple time they have asked in ISRO examination. If you try to observe the previous year solution of this IGC, right, sessions. Okay, so here, try understanding. Please try to see this question. Just a moment, guys. Here, just a moment.